Record. Good morning, sir.
Good morning.
Good morning, sir.
Good morning.
Good morning, sir.
Good morning, sir.
Sir.
Good morning.
Good morning, sir.
Good morning, sir. I am Shishir. Please give the rename option, sir. Shishir.
Rename option. I think rename option is in your.
Yes, sir. I am Shishir.
Share. Okay. Just open your mic. Unmute yourself. Shishir.
Yes, sir. Sir, that's my mom's name.
Okay.
In
Okay.
the screen name.
Just.
Yes, sir. I too need rename option. I'm B Sahiti.
Okay.
Sir, me too, sir.
Okay, I'm done.
Good morning, sir.
Good morning.
Morning, sir.
Good morning, sir.
Morning, sir.
Good morning.
Good morning, sir.
Good morning.
Good morning, sir.
Good morning, Shishir.
Good morning, sir.
Good morning, Sahiti. Okay, send that correction. Okay. 108 question. Question number 108. A and C both are correct. Huh? Both options. Okay. Fine.
Okay, sir.
Stomata. Just a minute. Huh? Can you see the screen?
Yes,
Yes,
sir.
sir.
We can see the
Yes,
screen.
sir.
Okay. So I repeat this part. Transpiration. Transpiration, it means loss of water in the form of vapors from the aerial part of the plant. Okay. The potometer is the instrument. It is the tool by which we can measure the transpiration rate. There are different types of transpiration. First is stomatal transpiration, around 90 to 97% through the stomata. They are present on leaves. Cuticular transpiration, through the cuticle, some amount of transpiration is possible, around 5 to 10%. And lenticular transpiration, it means lenticels. These are openings in the stomata, sorry, in the stem. And through this, it is possible 0.1 to 1%. Okay, sometimes bark is also involved in transpiration, around 1%, like lenticels. Okay, not important. Now stomata. So stomata, it is just opening, just aperture, stoma or mouth-like structure. One opening uh, uh, formed by two cells. These two cells are called guard cells. Okay, and these are actually epidermal cells ka modification. Epidermal cells are modified into guard cells. These are kidney shaped or bean shaped cells, and they form an aperture that is the opening of stomata. And this aperture is called stomata. Okay, and these guard cells are actually epidermal cells. They have chloroplast. Fine. Next, the inner wall of the cell guard cell, inner wall of guard cell is thick and non-elastic. Thick and non-elastic. The outer wall is thin as compared to the inner. It is thin and elastic. Thin and elastic. Okay. The guard cells are surrounded by helping cells. They are called accessory cells. Or subsidiary cells.
Sir, one scale-up shape, please.
Generally, the shape of guard cell is bean shaped.
Sir, this point is over.
No. Actually, I'm comparing here. There's a comparison. So generally, a guard cell ka shape, it is bean shaped, but
Sir, can you
it
scroll
is
up
easy
one
to remember.
point?
So, but the
Sir, what are
but
those
in
accessory and
grasses,
subsidiary cells named as?
these are helping cells.
Okay.
Helping cells. I will show you in diagram. But in grasses, in grass, the guard cells are dumbbell shaped.
Sir, we can say like in monocots it is double
Guard
shaped and in
cells,
dicots it is oval shaped.
not all monocots. Okay. Generally, grasses are there. Gramini family, especially, they have this type of shape, especially grasses.
Yes.
But yes, it depends on the option. If they give only monocot, suppose, okay. If you are asking, if the examiner is asking only monocot, it's okay, because grasses are monocots. But generally, we consider grasses only. So grasses, they have this shape. The guard cells are dumbbell shape. Dumbbell shape. Okay. The cell wall of dumbbell shaped guard cell is
So what's
Thick.
the second line, sir?
Are
The point
thickened
generally.
only. Generally, the shape of the guard cell is bean shaped, but in grasses,
Okay.
the guard cell shape it is dumbbell shaped. And in dumbbell shaped cells, the thickening occurs. The inner membrane, the cell wall, thickening occurs only in the middle. Only in the middle.
So, sir, over here the outer wall is thinner.
Outer wall is thinner in both cases. Outer wall is thin, inner wall is thick. So that at the time of entry of water, they are stretched. Okay, so the outer wall can be stretched because it is thinner, elastic, and the inner wall is thick, non-elastic. But because of this outer wall, automatically it is stretched. The inner wall is stretched, and because of this slight, a little opening is there. That is stomata. I'm showing you just a minute. Is it completed?
Sir, completed.
Yes, sir, completed.
Okay, so this is guard cell, which forms stomata. Okay, this is inner wall. So inner wall of guard cell, it is thickened. Both guard cells. It is not single cell, two cells. This is one cell. This is another cell. This is nucleus, protoplasm containing nucleus and yes, chloroplast also. So the inner wall, it is thickened. Inner wall of each guard cell, it is thick, but the outer wall is normal, that is thin and elastic. Fine. So suppose just
Sir, can you scroll up, sir?
okay, so guard cells, they are kidney shaped or bean shaped. Inner membrane or inner wall is thickened, outer wall is thin, and they have chloroplast. This is the structure of guard cell, and these cells, the surrounding cells, these are subsidiary cells. Around the guard cells. These are helping cells. Fine.
Sir,
Hmm.
sir, what is the function of this elasticity of outer membrane, sir?
If both membranes are non-elastic, so the water is there. So light turgidity is available, means this membrane or the cell, it cannot open this aperture. Okay, suppose these are the two cells, and they have overall similar structure of the membrane. Okay, so at that time, because of non-elastic nature, because thickened wall, it means what? It means it is non-elastic here. Okay, so no elasticity, so only slight turgidity is developed all over the sides, means uniformly you can say. Okay, water enters and it develops turgor pressure on the wall. Similar. So because of this, no opening of the stomata. So the shape is kidney shaped like this, and only this wall, it shows this turgidity, okay, stretching. And because of this wall is stretching, outer wall is stretching, this inner wall automatically
Just can you
it
scroll up
moves
the
towards
last
outside,
point?
this side and this side. So opposite direction they move, so this opening is formed. Any question? Hello.
Sir, can you scroll up? Sure.
What happens when they move in opposite direction?
The stomata is formed now. If this wall is still stretched on in this direction and this wall in the opposite direction, so definitely they pulls that each cell or each membrane, outer membrane pulls the thickened wall. Okay, so here one opening is created, one opening is produced. That is called stomata. Okay. Otherwise, and yes, it happens when the water enters the cell, guard cells. Otherwise, it is closed. It remains closed. Okay. So if you want to open the stomata, water entry is essential. Okay. So the cell becomes turgid, and because of the stretching of the outer wall, stomata becomes open. Is it clear? And there is a mechanism to explain this this method, closing and opening of stomata. Okay. Fine. So these are subsidiary cells. And these white cells, they are guard cells. Outer wall is thin.
Excuse me, sir.
Outer thin wall.
Sir, what is the role of
And
subsidiary?
inner, they provide water at the time of high osmotic potential in the guard cell. Okay. So these are
Will
helping
plant be
cells.
able to survive if God cells will not open and close?
Thick wall. When? Hello.
Sir, will the plant be able to survive if the God cells will not open or close?
No, it is not related to survive. Actually, the plant, they have stomata. Okay, so because of stomata, transpiration occurs. Okay, so they have an important role. I mean, they have their own role in this transpiration, and transpiration is responsible for ascent of sap. Okay, so indirectly it is related with this to the in this survival of the plant. Okay, because there is no any other case, there is no any one root pressure is also responsible for ascent of sap, but at certain height only, up to certain height. Okay, 20 feet or 50 feet or 100 feet only. But the plant, if the height is around 200 feet or 300 feet, then only the ascent of sap occurs through the transpiration. Okay, there is a theory, transpiration pull theory, so it explains means the ascent of sap to the farthest end of the plant. So here indirectly you can say yes, it is related with this survival of this plant, but not direct role. Okay, no direct role, because plants, they have lenticels also. Gaseous
Lenticels in the
exchange
stem, yes.
also, gaseous exchange is also it is because of stomata. So if the stomata are closed, gaseous exchange means here again the plant experience the problem. Okay, so
Sir,
the
all
rate
the
of
plants,
stomata, all the plants, they have leaves. Okay, if the leaf is there, it means stomata are present there. all plants, all angiosperm, gymnosperms. Okay, they have stomata. So stomata, they play an important role in photosynthesis. So indirectly they are related with that one. Agar suppose you cut the roots, so no supply of water, so there is no role of stomata. Stomata is open, there is no role. Okay. Even the stomata are open, they are
Their
open.
subsidiary
Means,
cells are also known as superized cells, sir.
no, they are normal parenchyma cells, thin walled cells. There is no suberization. Na? If suberization, it means the cell is dead. All cells are living cells. Guard cells are also living cells. Only the thickening occurs in the inner side of the wall. This is single wall. No? There is no differentiation. Means it is not first wall or second wall. Only the outer part of the cell wall, it is thinner as compared to the inner portion. That's it. So there are no two walls. Okay, outer wall, inner wall. It doesn't mean that there are two walls. Actually, the inner portion, inner part of the wall has thickening. Okay, it is thickened. So subsidiary cells, guard cells, outer thin wall, inner thin wall. Okay, and this opening here, it is called stomata. So stomata is formed by opening of, or you can say, by the guard cells, by their entry of water. Okay, by their stretching. If water moves out from the stomata, or sorry, from the guard cells, then this is the structure. So again, the cells become flaccid. The same concept is applied here, no? That exoosmosis, endoosmosis, DPD, osmotic pressure. So the guard cells, they become flaccid and the stomata is closed. Water moves out, so that there is no turgidity. So stomata closed. Closed stomata. Okay. In flaccid guards. Otherwise, if it is stretched, the stomata is open. Fine. So this is the stomata. Now, number of stomata, distribution of stomata on the leaf. So around 1,000 to 60,000 stomata are present in means 1 square centimeter. Okay, suppose this is leaf and 1 square centimeter of the leaf. Okay, so this part has, on the leaf surface, this part is around, means only this small piece. It has 1,000 to 60,000, contains 1,000 to 60,000 stomata, not complete leaf, only one part of the leaf, 1 square centimeter. Okay, so overall stomata, they form 1 to 2% of the leaf. Okay, 1 to 2% of part of the leaf surrounded by, covered by. Okay, this is distribution. So next, not distribution. Here, number of stomata, number of stomata on the leaf surface is about 1,000 to 60,000. per centimeter square. The 1 to 2% part of the leaf is covered by or surrounded by stomata. Yeah. Okay. Generally, the question is, generally stomata are present on upper surface of the leaf or lower surface of the leaf?
Upper surface, sir.
Lower.
Sir,
Lower
No, no,
lower
lower
surface.
surface of the leaf, sir.
Or lower surface of the leaf? Huh?
In dicots, upper surface, in monocots, the lower surface.
In dicot, it is upper surface, more stomata. Why? Any reason?
For efficient
Means
the downwards, sir.
The stomata present.
stomata?
As dicots are more evolved, they want more sunlight, they are present in upper surface.
Okay. But there is no relation of sunlight and stomata, no?
They are
Stomata,
downwards so that
they
water
don't
cannot
require
be.
they don't require sunlight. Hmm? Any reason?
Sir, I think they are downwards because a lot of water cannot be loosed.
Okay, good, very good. To avoid transpiration, actually, what is transpiration? Transpiration means loss of water, no? Loss of water. Okay. So to avoid this loss of water, mostly the plants that develop their stomata on lower surface. Okay. The lower surface has less. Suppose this is plant, this is the leaf. So lower surface of the leaf, this is lower surface. Okay. So this lower surface has many openings. These are stomata. As compared to here upper surface, they have also stomata, but as compared to the upper surface, lower surface has more stomata to avoid transpiration, because direct sunlight strikes this epidermis. Okay. And if more sunlight is there, more temperature is there, it means more transpiration occurs. These are the factors. Now in night, no transpiration occurs most of the time if the humidity is available. So generally rate of transpiration is very low or stopped, okay, during night.
Someone's skin is scroll
But
up.
in presence of light, transpiration starts because of light, because of photosynthesis starts in the guard cells, and yes, because of light, slightly temperature increases. Okay. So because of this, humidity is removed around the stomata and again transpiration starts. So to avoid this condition, avoid this more loss of water, stomata generally they are situated, they are arranged on lower surface. Yes, but in monocot, dicot, okay, this is the condition in dicots. In monocot, what happens? In monocot, the stomata number is almost equal on both surface. Okay, so monocot leaf is called isobilateral. Okay, iso means similar, bilateral means two halves, two parts. So similar two parts. Okay, both parts are same. So isobilateral means both layers, both epidermis, they have almost same number of stomata, same frequency. Okay, but the dicot leaf is called dorsiventral leaf. Dorsiventral means dorsal part, ventral part. So both parts are different, both layers are different, so called dorsiventral. It is related with number of stomata. So dorsal part, it has more stomata. Dorsal part, interestingly, it is the lower part. Lower part of the leaf is dorsal, and upper part, that is dark part, that is ventral part actually. So it is not dorsal. Upper is not dorsal. Upper is which is smooth. Okay, if you touch that leaf, that is smooth. Okay, it has a smooth feeling. So this is upper part, and this is ventral actually. The lower part where veins are visible, okay, slightly rough part, that is actually dorsal part. So dorsiventral. So lower part, which is dorsal, it has more stomata than ventral part, which is upper part. Fine. Okay. So more stomata on lower part, less stomata.
The upper part contain more number of chloroplasts, right?
Huh? This is because of epidermis, other epidermis, not guard cells. Okay.
No, sir, upper
epidermis,
part of the leaf
because
contain more number of chloroplasts.
more. Yes, because it is not because of guard cell, it is because of epidermis. Epidermis cells, they have more chloroplast, okay, rather than lower part. So that the upper part is generally darker portion, okay, as compared to the lower
It
part.
is greenish
is
than the
light.
lower part.
Yes, more green. Okay. So point is, what was the point? Yes, number of stomata. Number of stomata is
Sir, can
more
you scroll down?
on lower surface of the leaf than upper surface to reduce loss of water through transpiration. Okay, so this number is reduced on upper surface and it is more in lower surface. Okay, in xerophytic plants, okay, in xerophytic plants the stomata are present, but they are deeply inserted, not directly on the epidermal surface. Okay, they are deeply inserted and they are covered by means guard cells. Guard cells, sorry, they are the guard cells. They are covered by subsidiary cells. Okay, so in this case, suppose this is
So once can you
epidermis.
please scroll up?
So these are the guard cells
Yes, sir.
which
Thank
are covered by subsidiary cells also. So here the guard cells are inner side, deeply embedded. So no direct loss of water through the cells, okay, because they are covered by these subsidiary cells. They are deeply inserted.
Sir,
And this
even
type of
the
stomata are called
even the xerophytic stomata are closed in the day, right?
these are xerophytic. So they are called sunken stomata. Okay. I just want to let you the term sunken stomata. Sunken stomata means deeply inserted. So the water loss is reduced in xerophytic plant. Already there is a water scarcity in that environmental condition. Desert, suppose. So to avoid this transpiration, loss of water, because this is xerophytic condition, it means what? It means high temperature is there. Okay, and high temperature, it increases transpiration.
So in desert plants like
Opuntia, cactus.
yes, sir, cactus.
Yes, Opuntia, cactus, these are desert plants. So they have means a reduced type ka stomata, that is called sunken stomata. Okay, to avoid this transpiration. Okay, so next point, this is sunken stomata. Sunken stomata. So in desert or xerophytic plants, in xerophytic
Sir,
plants,
surrounding our subsidiaries.
they are surrounded by subsidiary. In xerophytic plants, stomata are completely covered by subsidiary cells. The stomata, because of this covering, the stomata are found below the leaf surface, not directly on the surface, leaf surface. This stomata is called sunken
Sunken stomata.
stomata. Sunken, S-U-N-K-N, sunken stomata.
Sir, in cactus there is no leaf. No, where are they found then?
On the actually the green part is stem. Okay, so they are in the this part. Or yes, they have spines. Okay, spines are present. So it is not leaf actually. It is stem.
Modified leaf.
Modified leaves. So they are modified. Actually, the leaf is converted into, it is modified into spines. Okay, so there is no stomata. But this leaf surface, it means what? It is that is stem actually, green colored stem, flattened body. And this arrangement is
Sir, this
to reduce.
Sir, this sunken stomata is present below the palisade parenchyma.
Palisade parenchyma, no, palisade is not available now because leaf is converted into spine. So this is a stem actually. The green part is a stem here. Okay, and here the sunken stomata.
Can you scroll up, sir?
This arrangement is reduced to loss of water, and not only cactus. The cactus is not one example of xerophytic. Okay, there is acacia. Acacia, or in Hindi it is called babool. Okay,
Yes, sir, acacia desert
babool
plant.
is acacia. Yes, that is also desert plant, and it has the leaves. Okay, it is actually desert plant. Opuntia is not true desert plant. Okay, in morphology, not in morphology, and in ecology, we will study. Okay, there are different types of xerophytes. Okay, annual, ephemeral, drought resistant. Okay, so these
Nopal,
endurers, drought endurers. So different varieties of xerophytes, not only cactus.
sir,
Right?
Nopal as well.
Yes. So these are the even the Ziziphus. Ziziphus means bear. Okay, bear. Small reddish colored fruits, greenish reddish. So that is bear. Bear is also it's called Ziziphus. Ziziphus jojoba. That is also a true xerophyte. Okay. So they have
Sir,
leaves. So in
so we
these
can
leaves,
consider the date plant as well in this property of function.
Date plants also. Date plants, they are desert plants. Okay, they are xerophytic. They are xerophytic. Here, different varieties of xerophytic succulent plants. So this is cactus. Cactus is succulent. Succulent means they retain water and mucilage in their body. Okay, so they are not actually xerophytes. They store water. Okay, to
Sir,
fight
will
this.
aloe vera come
To
in?
survive.
Aloe vera is also, that is succulent. Bryophyllum is succulent. Aloe vera, Aegobarbadensis, Opuntia, cactus, many
They
varieties are
store
there.
water for
Different.
their future.
So they actually they store water and mucilage. In aloe vera is the best example now. That aloe vera gel is actually stored water and mucilage in the body. Okay, so you cut that one and that mucilage material, it is coming out. Okay, that is stored water for their to fight that resistance, to fight that scarcity of water. Fine. So these are called succulent plants. Succulent means they have some mucilage and water as in stored form. They are succulent. They are not true xerophytes. They have some technique to fight this water scarcity. But babool, acacia, they have no, means these are true fighters. Okay, means they have no this type of mechanism, this type of any technique. Okay, so these are true xerophytes.
Sir, leaves
They
are
have different
converted
types of
into.
adaptation.
So leaves are converted into spines to decrease the surface area of exposure.
Yes, because leaf, if the leaf is present, suppose, so here transpiration rate increases. So they convert their leaves into spines. Okay. So
Yes.
there is spine means this is the dry part, brownish dry part here. No chance of transpiration. Okay. And the photosynthesis, it is done by that one. It is taken over by a stem. That is flattened part. So here stomata are present but in sunken condition. Okay. So again, no chance of transpiration. So by this method, plus to store water and mucilage, they can fight. Okay. So
Sir, then
xerophyte
all
doesn't mean only the
xerophytes
cactus
don't
is
have leaves.
xerophyte. Huh?
All xerophytes don't have leaves then.
No. That is why I'm saying now, xerophyte doesn't mean only the cactus. Cactus has no leaf, but other xerophytes, which are true xerophytes, they have their own leaves. Argemone mexicana is there, Ziziphus jojoba, acacia. Okay, they have the leaves, but they have different some another type of technique to store water or to fight that condition. Okay. So
Sir,
xerophytic
can
plant.
you
That
scroll
is
down?
why here they consider that yes, leaf surface is present. Okay, leaf surface. It means the xerophytes, they have leaves. Cactus has no leaves. That is a different point. Okay. So stomata are present in xerophytes. They are called sunken. The main point, the question is here. Sunken stomata are present in xerophytes. Okay.
So then in xerophytes,
Next.
parenchyma is also
In
not present.
hydrophytes, no, parenchyma is present. Parenchyma is simple tissue. No? Normal tissue is called parenchyma, just like your connective tissue or epithelial tissue.
Yes,
Most abundant tissue in the body is connective tissue. Okay. And connective tissue means what? Connection between two different parts. Most abundant part is connective tissue. Similarly, most abundant normal tissue, filling tissue is parenchyma in the plant.
Parenchyma.
Yes. In case of plant, it is parenchyma. In case of animal, it is connective tissue. Okay. In what was the point? In hydrophytes, stomata are generally absent. Huh? If present, they are non-functional. Okay, so they are non-functional. First of all, stomata are completely absent in hydrophyte because there is no loss of water. They are immersed plant. Okay, so generally there is no requirement of ascent of sap and all that because the importance of transpiration is to perform ascent of step so that water can move upward. This is the point. Okay, what is the requirement of transpiration? So transpiration is required for ascent of step. This is the main point. But if the plant is immersed in the water, there is no requirement of ascent of step. Okay, the all parts they can absorb water, all cells direct
Sir,
they
then
can
how
absorb
do they
water.
respire?
Huh?
How do they respire?
I'm saying now this is the plant surface. Plant surface absorb water directly. So if the water, if they can absorb water, automatically the oxygen or the gaseous exchange is also possible through the membrane, through the plant body. So there is no requirement of stomata. There is no requirement of particular gate. Okay, complete body is actually, it is capable to perform photosynthesis. Even you can see in the hydrophytes, the stem is also greenish in color. Okay, so they can perform photosynthesis. Okay, so photosynthesis or respiration, it can be done by the complete part of the body. Most of the part is
Like
just leave the roots only.
hydrilla, sir.
Hydrilla, Potamogeton, Wolffia, Trapa, Tinospora, so many examples are there. Okay, so they can perform this. Means there is no requirement of this stomata, no requirement of transpiration. They are already in water, no? Okay. Okay, fine. So hydrophytes, they have no stomata if they are present. Suppose if it is present, like Potamogeton. So Potamogeton, they have stomata. Okay, but non-functional. Non-functional, it means there is no mechanism of opening and closing, and it doesn't matter. No? If it is present but it is not working, so it is almost absent. No? It is like absent. So Potamogeton have stomata, but not functional. Okay, so overall there is no importance of stomata in the hydrophyte, but yes, in mesophyte they are completely developed. Okay, so two extreme conditions. One is xerophytic condition, stomata are present but sunken to avoid this transpiration, and in hydrophyte stomata are absent or non-functional. Okay, fine. This is distribution of stomata. Okay, next is the type of leaf on the basis of arrangement of stomata or presence of stomata. Okay. So first of all, this is one leaf. It is, suppose if the leaf or if the stomata, if the stomata are present only on lower surface. Generally, on lower surface it is more, the number is more, and on upper surface it is less. But suppose, means some plants they have only the stomata only on the lower surface of the leaf. Okay, the leaf is called hypostomatic. Okay, hypostomatic condition. Hypostomatic, it means only the lower surface. Hypo means lower. Okay, hypo and hyper. Hyper means more, upper. Hypo means less, lower. So here
Sir, we said
hypostomatic
tonic, hypotonic, and isotonic, sir, this part.
yes, hypotonic, it means what? Less concentration. So hypo, less concentration. Hyper means more concentrated. Solutes are more, so hyper. Okay. So this is hypostomatic leaf, means stomata are less. It is hypo. Sorry, stomata are lower, not less. Here the meaning is less, lower. So stomata are present only on lower surface, that is hypostomatic leaf. If the stomata are present only
Sir,
on
lower or less?
upper surface, no, lower. This is lower. I give this
Okay.
definition here. The stomata are present only on lower. So they are present, but only on lower surface, not in less amount, less quantity. So this is not related with number. This is related with presence. Okay.
Okay.
Yes. So if they are present on lower surface, it is hypostomatic. If the stomata are present on upper surface only, are on upper surface, the leaf is called, not stomata, leaf is called. The
Hyperstomatic.
leaf is called hyperstomatic. Yes. It is hyperstomatic. Okay, hyperstomatic. So if both surfaces have almost same number of stomata, both surfaces have means stomata. Okay, so in that condition, it is not isostomatic. Okay, it is called amphistomatic. Amphi means both, two. Okay, and yes, one more. If the stomata, just a minute, it is hyperostomatic when another term is used. It is not only hyper, but the term is epistomatic. That is more correct. Epistomatic. Epi means upper side. Okay. Hypo means lower side, like this. So it is not related with hypertonic solution or hypotonic solution. Okay.
Excuse me, sir.
Here epistomatic leaf.
As hydrophyte do not contains the waxy portion, as they are present on water, so no need of transpiration. If the excess water is being formed in the plant, how does it remove it?
No. Actually, they don't absorb water. There is no requirement of absorb of water to ascent of sap. Okay.
Okay, they
Water
just
is
observe
generally
oxygen.
in. Hello.
They just observe the oxygen.
Oxygen. Yes. It is only for gaseous exchange. Okay. Because there is, yes, they have cuticle or waxy layer to avoid that harmful effect of water. Okay, you can see in the submerged plant the leaves are ribbon shaped, long and ribbon shaped. Okay, dissected leaves, they are called dissected leaves. These are not like a normal mesophytic leaf like this. Generally these submerged plant, they have these long ribbon shaped leaves like this. Okay, I'm not talking about the surface plants. Okay, lotus, they have the particular regular size of the leaf, no matter, but the submerged plants, okay, they have these dissected leaves to avoid this water current also. Okay, so this is modification. Similarly here, no requirement of ascent of steps, so stomata is non-functional or absent, but yes, gaseous exchange, it occurs through the body surface directly. Done?
Sir, in hydrophytes, cuticle is
Cuticle is present, no? Cuticle is present to avoid, it is not for to prevent loss of water. Here this waxy layer is to avoid that harmful effect of water to plant. Okay, otherwise in the water it spoils the plant, it destroys the plant after some time. So to avoid this condition, a oily or waxy layer is there, that is cuticle.
Sir, my skin is cooled down.
Next
sir, in
is
xerophytes.
in
Sir, in
xerophyte.
xerophytes, it is
Yes, these are two extreme conditions. I earlier said these are two extreme conditions. In the xerophyte, the role is different. The
Yes,
role of this
it
cuticle is
controls the
different.
transpiration.
It controls the transpiration. It reduces the loss of water. Okay.
Okay, sir. Thank you.
Next is if the stomata are equally distributed, the stomata are equal on both surface. On both surface. The leaf is called
Amphistomatic leaf.
amphistomatic. Amphistomatic. Okay. Amphi means two types or two environments. Okay. Two layers. So amphi, common. This is common. So amphistomatic. So it is common both surface, same number or almost similar frequency. So that is amphistomatic. One more, if the stomata are present more on lower surface and less on upper surface, so same term we use hypostomatic. The leaf is hypostomatic. It doesn't mean that only the lower surface has stomata and upper surface the stomata are absent. Okay. Here again, same term we use hypostomatic leaf. So hypostomatic means only on the lower surface.
Lower surface, the stomata are more.
Or lower surface has more stomata than upper surface. So you
Upper
can use
surface.
same term, hypostomatic. Okay. So these are three main terms: hypostomatic, epistomatic, and amphistomatic. Hypostomatic means stomata are on lower surface. Epistomatic means stomata are on upper surface, and amphistomatic means both surfaces have equal number of stomata. Okay, equal number. So different examples are there, but not important. The terms are important here. Okay. Now, generally stomata they are generally open during daytime. Okay, in light. In light, they generally open. Okay, because of the photosynthesis occurs and all that, means there is a theory actually. So according to that theory, most of the stomata they open during day and generally they remain closed at night. Okay?
In the night time.
Yes, generally they close at night. So after evening, there is no role of stomata. Generally they remain closed. Okay. So this type of stomata, they are called photoactive stomata.
Phototrophic stomata.
No, photoactive. Phototrophic nahi hoga, because phototrophic it means it is related with movement. Okay, so it is not phototrophic. It is photoactive, means in presence of light they are active. So generally the stomata open in day and are closed during night. These stomata or this type are called photoactive stomata. Photoactive stomata. In presence of light, they are active. So photoactive. On the other hand, some cells, some plants, succulent plants, succulent or
Parasitic plant.
xerophyte. Okay, so they have a different case. Means in these plants, the stomata generally they remain open during all the night and they are closed in daytime. Okay. In succulent plants, the stomata are closed in a daytime and open during night. So they have different terms. They are called
Photoactive.
scotoactive. Good. They are called scotoactive stomata. Okay. They have different mechanism of opening. Scotoactive stomata. In night, if they are open, scotoactive. Daytime they open, photoactive. Clear? So these are of two types.
Sir, once can scroll up.
Fine. Yes. From where? From which point?
Yes, sir.
This
Here
one.
only.
Oh, okay. Now the mechanism of opening and closing of stomata during daytime. Okay, means generally we see the normal opening and
Sir, can
closing.
you show the last point?
Yes, yes. Okay. Is it completed?
Sir, completed.
Sir, complete.
Yes,
The
sir. Done,
last
sir.
point. Okay, next. Opening and closing of stomata. So opening and closing of stomata, first of all, I will describe complete mechanism. Actually, what happens in this case, one theory is there, that is active potassium transport theory. Okay, potassium ion exchange theory it is called. Potassium ion exchange theory or active
Sir,
potassium
once please
transport.
can you scroll up?
So in this case, it was proposed by Levitt, first of all. Okay, this theory was proposed by Levitt. Levitt says that the guard cells, they have chloroplast. So obviously in presence of light, they form starch, they form sugar. Okay, in presence of light, fine, chloroplast, they perform photosynthesis. So starch is formed. In presence of light, what happens? The already available starch, which is already stored in the guard cell, which is available in the guard cell. Suppose this is guard cell and these are the stomata. These are guard cells. So this guard cell, it has chloroplast which perform photosynthesis. It forms sugar. In presence of light, the sugar which is stored as starch in the cell, in presence of light, it is converted into organic acid, that is called malic acid actually. So it is converted into malic acid. Okay. First of all, the starch, it forms phosphoenol pyruvate, then it combines with CO2 and then oxaloacetic acid. So there is a long reaction. Okay. And then finally it is converted into malic acid. Okay. Now malic acid, don't write this one. Huh? Don't write this one. I will make complete notes here one by one. It is just to understand. So starch is converted into malic acid. Malic acid splits into mallet plus HIN, mallet ion and HIN. Okay. These HINs, their concentration is increased in the guard cell. So HINs from the guard cells, they move outside. Okay. So they are transported in the epidermal cell where HINs are less. Okay. So they are moving outside the cell. And in turn, the potassium ions, they enter the guard cell to compensate this decrease.
So your voice is breaking, sir.
Your voice is clear, sir. Sir, voice is clear. It seems.
Sir, it's breaking, sir.
It's breaking, sir.
Somewhat it's breaking.
Breaking, sir.
It's
Not
clear for
audible
me.
now, sir.
Sir, cannot hear you only, sir.
Can you hear me?
Yes, sir. I
Now
can
it's
hear
Yes,
you.
sir. We
Yes,
can
sir.
hear.
Yes, sir, now you're audible.
You are audible, sir.
Okay. Okay. Okay, fine. I repeat, this is the mechanism of opening and closing of stomata. The stomata, they have chloroplast. In the chloroplast, starch is stored here. Starch in light, in presence of light, it is changed into malic acid. Okay. Now malic acid splits into mallet ions plus H ions. Okay. This H ion, it moves outside. These H ion, because of concentration gradient, they move out from the guard cells. Okay. To compensate that one, to maintain the equilibrium, potassium ion enters the cell because the cell membrane is permeable for potassium ions. So potassium ions are taken inside the guard cell, into the guard cell. Okay. So this complete process is called potassium ion exchange or just ion exchange. Is it clear? So this is potassium ion exchange. Okay. Now what happens? This potassium ion, it combines with mallet, which is already available in the guard cell, and it forms potassium mallet.
What is millet?
It forms potassium mallet. Okay, fine. So this potassium mallet, it increases osmotic pressure, or you can say osmotic concentration. Potassium mallet is formed here. So in the guard cell, potassium mallet increases osmotic concentration. Okay, and because of this, osmotic pressure increases of guard cells. So guard cells, they absorb water from the subsidiary cells. Yes. So water enters from the subsidiary cell, surrounding subsidiary cell into the guard cell. So what happens, as you know, this is the cell with thick walled and thin walled structure. So automatically the water, it exists, it exert one pressure on the wall. But the problem is the inner wall is thickened and non-elastic, so there is no effect of this pressure. So this pressure, it is increased on outer wall, which is thin and elastic. Okay, so it is stretched. Suppose this is the original position and this dotted, that is after entering of water. Okay, so it is stretched. Okay, it pulls out. So because of this, here again the next membrane, this is closed guard cell or closed stomata, and because of entry of water, the outer wall is elastic, so it is stretched, so it moves outside. Now it moves outside, and because of this, this inner wall is also, it is pulled out with the outer membrane. So one opening is created. and this opening is called stomata. So because of this, stomata is formed, or you can say stomata is open. Is it clear? Are you getting me?
Yes, sir.
Yes, sir.
Clear.
Yes. So this is the method. This is the method. Just
Yes, sir.
start from starch. Starch forms malic acid. Malic acid splits into malate H-ions. H-ions are moved out. They move from the cell. Because of this, potassium ion enters the cell. Potassium ions combines with the malate. They form potassium malate. Potassium malate increases the concentration. If concentration increases, it means its DPD increases. Its hunger increases. It becomes thirsty. So DPD increases. Water enters the guard cell from the subsidiary. Its absorption power, its suction power is increased. So it absorbs water from the surrounding cells. It becomes turgid. Stomata open. Just reverse reaction occurs during closing of stomata. Okay. So here in this case, the sugar formation is stopped. Okay. The malate ion, the potassium ion actually. Here one more thing actually. Abscisic acid again, one hormone is there. Okay, auxin, cytokinin, ethylene, gibberellic acid, and abscisic acid. These are plant hormones. Okay, we will see in plant growth and development.
Growth promoters.
Yes, so this is the abscisic acid, which is actually growth inhibitor, and it plays an important role in closing of stomata. So abscisic acid, it becomes active. Okay, and here CO2 concentration increases because in night generally photosynthesis is stopped. So no requirement of CO2, no use of CO2. So CO2 increased, CO2 concentration increases. Okay, so presence of CO2, presence of abscisic acid, it initiates closing of stomata, and here it splits the potassium malate. Okay, this potassium malate, it is dissociated into potassium ion and malate ion. Now this malate, this H ion, it enters the cell. It enters the cell here, and it combines with the malate to form malic acid and finally starch. And potassium ions, they are pushed out. And because of this, the cell become, the water molecules, they move out and the cell become flaccid. Stomata are closed. Okay. So the
Sir,
reverse
is
reaction
this
is not much
rhythmically?
important, but the
Does the stomata closes and opens rhythmically, sir?
rhythmically, yes, this is the rhythm. Rhythm means day-night rhythm. Day-night rhythm is there, so-called photoactive. So rhythmically, it is possible. So during day, malic acid is formed, and because of this, H ion concentration increases because of this splitting of malic acid, and stomata are open. During night, it becomes flaccid because of this exosmosis occurs in presence of more CO2 and abscisic acid. So the stomata are closed during night. Okay, so this is a rhythm, day-night rhythm. Done?
Sir, even in daytime also it is continuously open or it will be closing?
No. In daytime, again, there is different period of.
Sir, your voice is
closing.
breaking, sir.
It depends on that environmental condition also. It depends on environmental condition actually. If the high temperature is there, okay, high light intensity is there, suppose, so at that time stomata are, they are open, fully open. Okay, if humidity increases, suppose this time, this is rainy season now, so in rainy season generally the environment is more humid. So in this condition, stomata, there is no requirement of transpiration. So here transpiration is less in this condition in rainy season. If you increase the temperature around the stomata, it removes that humidity. So again stomata will open. Okay, so it doesn't mean that once if stomata are open, so they will remain open throughout day. Okay, So it
Yes,
depends on
yes.
that. Yes, depends the condition. CO2 concentration increases, stomata will close. If temperature increases, stomata open. If humidity, it is inversely proportional. Okay. So humidity increases, stomata closed.
Yes, sir.
So these are different conditions. Okay. Physiological condition is also if suppose in plant if abscisic acid concentration increases, okay, abnormally. So again it will close the stomata. So it is means it depends. Even in night, if you're giving light to the stomata or to the plant, okay. So if we use light, stomata are open, okay, because in light photosynthesis starts. Okay. So again concentration increases. Again same process, potassium ion exchange.
So
It starts
transpiration is directly proportional to light.
to light. Yes, to light, to temperature. Uh, yes, directly proportional. Abscisic acid, CO2, and humidity, inversely proportional.
Yes.
Okay. So this is opening and closing of stomata. I'm writing here. Uh, Potassium ion exchange theory. Potassium ion exchange theory. Okay. Proposed by Levitt.
Sir, are scientist names asked in NEET?
In light, what happens? So during day or light, first of all, starch is stored in guard cells. It is stored in guard cells. This starch in presence of light, this starch is converted into malic acid. Okay. Malic acid, it is unstable, huh? So malic acid splits into malate ions
Millet and
and H ions. It occurs in the guard cell, huh? Complete mechanism in the guard cell. So here H ions are formed. HR concentration increases and they are transported to epidermis. To maintain HN concentration, to maintain positive ion concentration, or the equilibrium. Okay.
Sir, can you please scroll up?
So to maintain positive ion concentration, potassium ions enter the guard cell. Potassium ion enters the guard cell. Potassium ions combine with mallet ions to form potassium mallet. Potassium mallet increases osmotic concentration of the guard cell. Okay, so concentration increases.
Once, can you scroll it up?
Yes, yes. Water enters the guard cells from the subsidiary cells. This is the starting of potassium ion exchange theory. So first in light, this phenomena in guard cell, starch is converted into malic acid form H ions plus mallet, H ions move out, potassium ion enters the guard cell, they form potassium mallet. Is it completed?
No, sir, can you show the first part?
Completed.
Okay, just a minute. This is the first part.
Thank you.
Okay.
Sir, can you
So
show the last?
this is the last. Water enters the guard cell from the subsidiary cell. So
Sir,
what
can you
happens?
scroll up to 50 points, sir?
From which point?
50 point to maintain positive.
To maintain. This is the point. Okay. So water enters the guard cell from the subsidiary cell. The cells become turgid. The guard cells become
Excuse me,
turgid.
sir. Sir, can you please scroll up to opening and closing of
Stomata.
stomata due to net issues? I'm not able to complete.
Yes. Just a minute. Stomata open. Okay. So this is opening of stomata. I'm showing you from the starting, potassium ion exchange theory. So you can take a screenshot. I think it is done.
So a bit more up.
This one.
Excuse me, sir.
No, sir, before potassium exchange that. Yes, sir.
Yes.
Here, 1 second.
Somebody is asking.
Sir, sir, I have a doubt, sir. Sir, the inner walls
Yes,
of
sir, it's done.
guard
Thank
cells.
you.
Sir, the inner walls of guard cell is thick and elastic or non-elastic?
Inner wall is thick and non-elastic.
Sir, in NCERT is given elastic, sir.
No, it is non-elastic. It is stretched by, it is pulled by elastic membrane, that is outer membrane.
Sir, it's
It is non-elastic and thickened.
it's given the line is just line as sir, the inner wall of each guard cell towards the pore of stomatal aperture is thick and elastic.
Okay, and outer wall?
And outer one it's not given, sir, but it's given in inner one.
No. Only if inner one is elastic, suppose this is inner wall. Inner wall is elastic. Okay. So, okay, this is non-elastic according to us. This is non-elastic, sorry, elastic according to NCRT, suppose.
Sir,
So
can
what
you
will
please
happen? It means
just take a
what? It
screenshot?
means, and if it is not given in, just a minute, just a minute. So if it is elastic, what will happen? It means water, it pressurizes this wall towards the pore, no?
It will not open.
So it becomes oval shaped. Okay, it becomes oval shaped. It means no chance of opening of stomata. This is the logic, no, behind this. If both the wall, inner wall, it is elastic. So what will happen? The pressure is exerted overall the wall. It feels that pressure, no, from the water. So it becomes turgid. It means this wall, it is pushed inside. Okay, so no stomata opening is there. Okay, because of this, the guard cells, they have kidney shaped structure, so that they can pull the outer membrane. It can pull the inner membrane, which is non-elastic and hard, non-elastic and thick. In NCRT, many points are given, but there is a, you can say, means what will I say? This is wrong completely. Okay, it is illogical. No? If the guard cell, it has thick wall, inner thick wall.
Sir,
Sir,
there's
can
one
you
more line,
explain
sir.
once again?
Sir, there's one more
Is
line,
it
sir. Can you
given the
explain me?
explanation?
Sir, उसमें लिखा है कि when the guard cell lose turgor due to water loss, the elastic inner walls regain their original shape. The guard cell becomes flaccid and stoma closes.
But it is applicable on outer membrane, no? Outer membrane loses its turgidity. Okay, so because of this, it is elastic, so it becomes in normal condition. So automatically this membrane, inner membrane, it is not now stretched. Now it becomes in its normal position. So the stomata is closed. It is just opposite. We generally we explain to understand the stomata opening and closing. Okay. I have to say this point, otherwise it is not correct. Okay, it is not correct. The outer, you can see the questions also. Questions related to the thickening of stomata and elasticity, non-elasticity of the cell wall. Okay, you can see the question. Generally, this is the concept. This is the point that outer membrane is stretchable. Outer membrane is elastic, so that it can pull the membrane, inner membrane. The stomata is opened. If it is flaccid, again it regain its normal position. So the stomata are closed. Okay. So we'll see this point in NCRT. Otherwise, this is completely wrong. Okay.
Okay, sir. Thank
You
you.
are Pritam or Varun? Who is it?
Sir, it's Aditya Kumar.
What's your name?
Sir, Aditya Kumar.
Aditya. Okay.
Yes, sir.
Okay. Aditya, no? Aditya. Okay.
So can you scroll up now?
Fine. The guard cells, they become. Hello.
Yeah, thank you, sir.
Is there any doubt? Okay, fine. So the guard cells, they become turgid and stomata open. Okay.
Sir, so if
Now,
the wall is thick means it have to gain concave shape. That's why inner wall is thick.
Inner wall is?
Inner wall is thick because it have to gain a concave shape, right?
No, shape is there to means to ease of this uh, stretching. Okay, and the stomata is easily opened. Okay, this is the concave shape, and
Yes,
this
sir.
is convex.
Yes, sir.
So the shape is different thing, but Aditya is saying that in NCRT it is showing this is elastic. Okay, but it is inelastic. The point is there here. Elasticity or non-elasticity of the inner membrane, outer membrane. This is the point.
Yes, yes.
But shape is different. Shape also helps in opening and closing of the stomata. Fine. This is opening of the stomata. Now during night, uh, water enters the guard cell. From the subsidiary cell, the guard cell becomes turgid and stomata open. Okay, fine. So in this case, endoosmosis occurs. All the means this is the point may be possible. They will ask which phenomena is there. So it is endoosmosis. Just a minute, I have to write here. The guard cells become turgid because endoosmosis occurs. Guard cells absorb water from subsidiary cells because of endoosmosis. So endoosmosis occurs. Okay. In dark or in night, so what will happen here? CO2 concentration increases because photosynthesis is stopped during dark, during night or in dark. Okay, no photosynthesis. Photosynthesis is stopped. It is not stopped, it is absent. Okay. It is absent. CO2 concentration increases in guard cells. Decreases. So it reduces pH of the cell.
Thus, can you scroll up, sir, once?
Abscisic acid
Stop it.
is active in presence of CO2. Abscisic acid ABA, okay, changes the permeability of the membrane. Permeability of guard cell or the membrane of the guard cell. Fine. And because of this, potassium ion entry is stopped, even they are pushed out from the cell.
So one scroll up.
Just
So what is
let me
this
finish this
ABA?
point. Abscisic acid. Its abbreviation is ABA. Now, potassium ions are transferred guard cells to epidermal cell again. Okay. Anions enter the guard cell and combine with millet to form malic acid. At a reduced pH is converted into starch again. It lowers the pH, it lowers the osmotic pressure. Guard cells.
Can you scroll up, sir?
So just a minute. So water moves from the guard cells the cells become flaccid and stomata are closed. Yes, I'm showing you from the starting in night. Okay, from this point.
The last point.
I need the last point.
Huh?
Show the last point, sir.
Just one. Is it completed?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, fine. Yes, yes. So I'm showing you from this last 3 points. At low pH, malic acid is converted into starch again. Okay.
Sir, what is the last point?
The cells become flaccid. Cells means guard cells. They become flaccid and stomata are closed. Flaccid means water is moving out.
Okay, sir.
Okay. This is the theory. Potassium ion exchange or active potassium ion transport. It is also called active potassium ion transport. Just a minute. At this point here, potassium ion exchange theory, it is also called active potassium ion transport. It is active process. It means here ATP is used. Okay, ATP is used here in this process. Okay.
Sir, can you repeat what is
Done?
potassium ion
Huh?
transport?
Just a minute. Potassium ion exchange theory. I wrote here active potassium ion transport. Okay. So it is called potassium ion exchange theory or active potassium ion transport theory. Maybe they ask like this, active potassium ion transport. So it is same, huh? Potassium ion exchange theory to explain opening and closing of stomata. Okay. Now, in the last
Sir, in
point.
daytime, K malate is solute. In daytime,
Sir, show the last point.
In daytime, solute is
K malate.
Solute is accumulated. What are you saying?
Solute is K malate, no sir.
Potassium malate. Yes, potassium malate is the solute. It increases osmotic concentration. Correct.
Yes.
Potassium K malate means potassium malate. Huh? Okay. Now, factors. Different factors affecting transpiration.
So once please go on
What are the
it, sir.
factors?
Okay, sir. Thank you.
Done? Is it completed?
Yes, sir.
So factors.
Yes.
Factors may temperature. Temperature. Okay. So if temperature increases, the rate of transpiration increases. Rate of transpiration increases. Okay. If we increase the temperature, rate of transpiration also increased. Okay, next it is light. So in presence of light, stomata open. Okay, so rate of transpiration increases. In presence of light, stomata open. So transpiration is increased. Okay, transpiration is increased. Next, wind. So generally, wind increases transpiration. Okay, wind removes humidity. Okay, so generally, relative humidity is removed from wind and temperature also. So if wind is there, it means rate of transpiration increases. Removes humidity around the leaf and it increases rate of transpiration. Okay, so wind also increases rate of transpiration. But yes, one another point. Very high wind velocity. Okay, very high wind velocity. First, it increases transpiration. Then, because of a very high rate of transpiration, the stomata are closed because excessive loss of water. So they become closed. Okay, and because of this, transpiration is stopped. Okay, this is one point. Second point, high wind velocity, it lowers temperature also around the leaves. Okay, so transpiration is decreased. High wind velocity or storm ka condition. Okay, normal wind, it removes humidity mostly, so it increases rate of transpiration. But the second question is high wind velocity. Okay, decreases transpiration. Fine. Pressure, atmospheric pressure. Generally, as we go up on hills, atmospheric pressure decreases. Okay, so decreased atmospheric pressure, it increases transpiration. Is low, decreased. It increases rate of transpiration. Okay, so as we go on hill, so directly they will ask like this: on hilly area, the rate of transpiration. So rate of transpiration is increased. Okay, if pressure is decreased, transpiration increased. Now, the inversely proportional, that is humidity. So if humidity is there around the leaf, transpiration rate is decreased. Amount of vapor, okay, amount of vapor present in the environment, in this atmosphere, okay, it decreases transpiration. If relative humidity is low, then rate of transpiration is high. Is more. Okay, means it is inversely proportional. If relative humidity is higher, then transpiration is decreased. Even water also affects transpiration. If water abundance is there, means more water is available, more absorption is there. Okay, sufficient absorption is there. So it means more transpiration occurs. Transpiration rate increases. And on the other hand, if the water is not available in the soil, so very less absorption or no absorption occurs. So there is no chance of transpiration. Okay. More availability of water in the soil increases water absorption. And hence the rate of transpiration increases. Hence increases. Okay. If water absorption is stopped, transpiration no transpiration occurs. Okay. So these are some factors related to rate of transpiration. Okay. One more point, some chemicals, some substances, they are also, they reduce transpiration. They do not increase transpiration, they reduce. So they are called anti-transparent, means they are anti of this transpiration process. Okay. So some are anti-transparent.
Sir, one scroll up, sir, till AMT break.
Anti-transparent. Okay.
Thank you, sir.
So anti-transparent, it means they reduce a rate of transpiration by their presence. Okay. Some substances reduce transpiration by their presence. Okay. So these are abscisic acid, ABA. If its high concentration is there, it reduces rate of transpiration. CO2 is there. So if CO2 concentration increases, automatically stomata are closed and no transpiration. Some other materials like PMA, it is called phenyl mercuric acetate. Phenyl acetate, sorry. Acetate. Okay. It is called PMA. Silicon oil. Silicon emulsion or silicon oils. So these are some Yes, one more. Aspirin. Aspirin. Salicylic acid. They are anti-transpirants. Okay. Is it completed?
So can you scroll up at the starting of this factors?
Yes, sir, completed.
Completed, sir.
Fine.
So
Sir, the
nearly to
line.
complete, sir.
I'm showing you the factors. Okay. This is transpiration. Okay. The last point is there. Just a minute. Huh?
Done,
We
sir.
can add here also. Okay. Done.
Is class finished?
So add this one point here. That is also important. Huh? Just a minute. Just a minute. Just a minute. This last point. Anywhere you can add this one. Actually, Curtis says transpiration is necessary evil. Okay. Transpiration is necessary evil. So sometimes they ask like, who termed this transpiration is necessary evil, or this statement was given by like this. Okay. So Curtis says transpiration is necessary, sorry, necessary evil by Curtis. Okay. And Stewart says transpiration is unavoidable evil. Of this, you cannot avoid this because it is important to um, to move water upward. Okay. So it is important in ascent of sap. If transpiration is absent, water cannot be moved upwardly. So transpiration is an unavoidable evil. It is evil. Evil means it is a demerit, you can say. Okay. By Stewart. So Stewart says it is unavoidable evil, and Curtis says it is necessary evil. It is necessary. It is a bad character, but it is necessary to move water upwardly for ascent of sap. It is unavoidable. You cannot avoid. The plant cannot avoid this process. Okay. And what is the importance of transpiration? It is here.
Sir.
Just a minute. Transpiration helps in ascent of sap.
So can we leave?
Yes, yes. If you are completed, but just
sir.
note down these 2-3 points. It helps in okay.
So transpiration helps in ascent of
Ascent of sap. It helps in ascent of sap. It helps in water absorption. It provides a cooling effect. It is the air conditioner of the plant. It provides an cooling effect. Leaves means it maintains that temperature also around the plant. You can feel this one in summer season. You can feel this point exactly. You feel some coolness under the tree because of the
Yes, sir.
yes, because of the transpiration. Fine. So these are the points. This is transpiration. Next point will be ascent of sap or bleeding something. So we'll take this one. Guttation also. Guttation, bleeding, ascent of sap. That's it. Okay. These are 3-4 points. And yes, sir. One more. Uh, 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 Munch hypothesis. Okay. Munch or Munch hypothesis. Yes. So 3-4 points are remaining. So we'll try to complete this part tomorrow.
Can we leave?
Thank you, sir.
Thank
Fine.
you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Bye,
Thank
sir.
you very
Thank
much.
Thank you, sir.
The transportation of land chapter when will finish, sir?
Thank you, sir.
When we'll finish the transportation of plant
An upcoming test.
finish
What are you
chapter?
saying? When it will be
When we
completed?
complete this chapter,
Tomorrow,
sir.
tomorrow itself will complete.
The next
Tomorrow.
week, new topic, sir.
That is mineral absorption, mineral something is mineral nutrition. Okay, it is mineral nutrition. The next topic is mineral nutrition. So we'll complete this part if we will have time. So we'll start mineral nutrition, the next part.
Okay, sir. Thank you, sir. Bye, sir.
Thank you. Bye, Rishikesh.
Thank you,
Thank
sir.
Thank you, sir.
Thank you, sir.
Bye.
Thank you. Bye.